Every year, millions of laptops are discarded. Here at this facility, we don't see trash. We see the future.
The journey begins in the heart of the city, where end-of-life electronics are collected to prevent environmental contamination.
Specialized logistics fleets gather materials from thousands of collection points across the state.
Tons of potential resources travel hundreds of miles to reach the processing hub.
Upon arrival, every load is weighed and cataloged to track material recovery efficiency. The receiving bay acts as the mouth of the facility, swallowing tons of obsolete technology every hour. This chaotic pile represents millions of dollars in recoverable gold, copper, and rare earth elements. Heavy machinery moves the raw stock to the initial feeding lines. The conveyor system begins the automated journey, transporting items to the triage station. Before handling the materials, safety is paramount. Hazardous components require manual intervention.
The triage line is the first filter. Human expertise separates items that contain volatile batteries.
These batteries are sent to a specialized chemical facility for separate recycling. Lithium-ion batteries pose a fire risk in the shredder, so they are harvested carefully by hand. Automated breakers separate mercury-containing LCD screens from the metallic chassis. Older screens contain mercury, which is extracted safely before the glass is crushed. The safe, stripped carcasses now head to the primary shredder, a beast capable of eating 5 tons an hour. Hardened steel blades rotating at high torque are designed to shear through aluminum, plastic, and steel boards.
In seconds, complex devices are reduced to rough shrapnel.
The output is a coarse mix of all materials, which must now be liberated from one another. Powerful overhead magnets instantly snatch steel and iron from the mix. To separate copper from plastic insulation, the material must be ground down to the size of sand. This steel is baled and sold directly to smelters to become construction rebar.
An eddy current rotor creates a magnetic field that physically repels aluminum and copper, launching them into a separate bin.
Advanced filtration captures hazardous dust, keeping the factory air clean and safe.
Optical sensors identify circuit board fragments, using air jets to separate the gold-bearing material from plain plastic. The plastic housing of the laptops is ground into chips, ready to be melted down. What was once wiring and heat sinks is now 99% pure copper, ready for refining. Density tables use water and vibration to wash the final plastics away from the valuable copper. The plastic housing of the laptops is ground into chips, ready to be melted down.
The circuit boards hold the real treasure. They are sent to an ultra-high temperature smelter to recover precious metals. What was once wiring and heat sinks is now 99% pure copper, ready for refining.
At 1200 degrees Celsius, plastic burns off as fuel, while gold, silver, and palladium sink to the bottom.
The molten alloy is poured into anode bars for electrolytic refining.
Through electrolysis, pure copper migrates to cathodes, while gold and silver fall to the bottom as sludge.
The final step yields 99.99% pure gold, recovered entirely from discarded electronics.
These recycled pellets are now a high-grade raw material, indistinguishable from virgin plastic. The clean flakes are melted down and homogenized in an extruder. Now, the cycle begins anew. Designers create the next generation of devices using these recycled specifications. The recycled plastic pellets are loaded into injection molding presses to create new laptop casings.
In seconds, trash has been transformed into a precision-engineered chassis. Recycled copper is electroplated onto new boards, ready for component placement. Automated mounting systems populate the motherboard with processors and memory.
The boards pass through a reflow oven, permanently soldering the connections.
Skilled technicians marry the new display panels with the recycled casings. The heart of the new computer is installed. Precision automation ensures every key is perfectly seated. The unit is sealed, completing the physical transformation.
Every unit undergoes rigorous testing to ensure it meets new product standards.
Laser scanners check for even the slightest cosmetic imperfection. Final detailing ensures the product looks untouched by human hands.
Even the packaging is part of the sustainable loop, made from 100% recycled fiber. Finished units are palletized, ready for distribution to schools and businesses.
Securely wrapped, the shipment is ready to leave.
The cycle is complete. What arrived as waste leaves as a valuable resource. From the scrap heap to the consumer, this factory proves that technology can be sustainable.
Old technology given a new life, powering the ideas of tomorrow.
Data security is critical. Storage devices are physically destroyed to ensure no data can ever be recovered.
To maintain efficiency, preventative maintenance is performed during shift changes.
This is the future of manufacturing. Circular, efficient, and essential.
Data security is critical. Storage devices are physically destroyed to ensure no data can ever be recovered.
Aluminum is infinitely recyclable, requiring only 5% of the energy needed to produce new aluminum.
Complex cooling systems regulate the temperature of the injection molding and smelting equipment.
Even the smallest components are handled by high-speed automation.
Recycled copper is drawn into hair-thin wires for internal cabling.
Every batch of recycled plastic is tested to ensure it matches the strength of virgin material.
Autonomous vehicles ferry parts between processing stations without human intervention.
Captured dust is compressed and treated, preventing it from entering the atmosphere. Even the glass from old monitors is melted down to create fresh display panels. Controlled cooling strengthens the glass for its new life as a touchscreen.
Lasers cut the glass to precise dimensions for the new display assembly.
Recovered cobalt and lithium are used to coat new battery electrodes.
These layers are wound into new power cells, closing the energy loop.
Internal harnesses are assembled by hand to ensure flexibility and durability.
Stress tests verify the mechanical integrity of the recycled materials. Random samples are drop tested to ensure the recycled chassis is as tough as a new one.
Laser etching ensures the keys never fade, adding the final details.
The glass touchpad, made from recycled screens, is seated with precision. Thermal interface material is applied to ensure the processor runs cool.
The cooling system, crafted from the copper recovered earlier, is installed.
Audio components are bonded into the chassis.
Antenna cables are carefully routed to ensure maximum signal strength.
Each unit receives a unique identity, tracking its origin back to the recycling batch.
The new battery systems are cycled to ensure they hold a full charge.
Cameras and microphones are calibrated for crystal clear communication.
Every port is physically tested for connection quality. The new battery systems are cycled to ensure they hold a full charge. This is the circular economy. This is the future of recycling.
Before packaging, the device must be visually flawless.
Every port is physically tested for connection quality. The new battery systems are cycled to ensure they hold a full charge.
Sealed and secure, the product is complete. Palletizing is automated for stability during transport.
Logistics teams move the finished stock to the shipping docks.
Trucks are loaded efficiently to maximize fuel savings.
Digital tracking ensures full chain of custody, from scrap to new product.
Documentation certifies the eco-friendly origin of the devices.
Heading to retailers and schools, the cycle is complete.
The new devices arrive at consumer outlets. Awareness is growing, and demand for green electronics is rising. Consumers now have the choice to buy completely sustainable technology.
The quality is identical to products made from virgin materials.
It looks new, it feels new, but it has a history.
Responsive, durable, and ready for work.
Schools are major beneficiaries of affordable, recycled technology.
Back at the plant, even the water used in processing is recycled.
The facility runs partly on solar power, further reducing the carbon footprint.
Protected in sustainable materials, it's ready for the box. Continuous investment in the workforce ensures the highest standards.
Products are tested to survive in extreme environments.
Back at the plant, even the water used in processing is recycled.
The facility runs partly on solar power, further reducing the carbon footprint.
The value recovered from waste is immense, funding the entire operation.
What comes in is processed rapidly, preventing stockpiling. Giving back to the community is a core part of the mission.
We are constantly designing for better dismantling in the future.
Complete destruction of data is guaranteed.
It takes a dedicated team to make this possible.
Technology and nature can coexist.
From scrap to precision. This is the circular economy. This is the future of recycling.